Okay, just been playing around a lot. Power batteries on the right, charging batteries on the left, and what I want to show is the blue trace is the shunt. The top trace is the power battery that's powering the circuit. It's at 12.3233% RMR voltage, and this right here, I have it connected to the battery getting charged up. And what I want to show is basically when I connect the ground of the charging battery to the common ground, we know that that will definitely charge up, and you can see the little voltage spikes hitting the battery getting charged up. Yellow trace is the power battery not having as many tall spikes coming back to it because it's going to the charging battery, and if I disconnect, you can see that the power battery has the bigger spikes again. Okay, now what I want to do is I'm going to take this ground from the battery getting charged and I'm going to hook it up Bedini SSG style, where the diode is going to the positive of the battery you want to charge up, then the negative of the battery you want to charge up is going back to the positive of the power battery. And you can see that the spikes on the battery receiving charge are quite a bit higher now, but at the same time you have a lot stronger spikes going back to the power battery as well. I'll disconnect it, and you can see how much they shrink down. So by adding that battery to the circuit, both are able to get charged better. See, here's disconnected, connected, charging battery, disconnected, connected, charging battery, disconnected, connected, charging battery. This is connected charging battery, where the ground of the charging battery is going back to the positive of the input battery, and when I let go, you got less going back to the front battery, plus it doesn't look as good on the shunt, plus it stabilizes it. So that's the SSG simplified charging method diode. From negative of the coil going through the diode to the positive of the battery you want to charge up. Negative of the battery that you are charging up is going to the positive of the input battery. And you're just going to have to draw out that schematic, and you'll see that that's the Bedini SSG charging method. And so both charging battery and front side battery receives more. So it's definitely a better way to connect it up. And you can see that charging battery is already at 13.59. And it was up to 13 point whatever, that was higher, but I've been playing around and tuning the circuit, trying different variations, and so anyway, I'm going to let it charge just like that. So it seems to be better for both, actually. So even though the second battery is charging, it looks pretty apparent that the front side power battery is receiving a majority of the benefit for super extended running time, plus charging up the battery more effectively. And of course, nothing beats the front battery running without a diode at all. That's where you just get the ridiculous crazy spikes going right back to the front side battery. By the way, the SSG charging method is that was an oscillation, by the way, full oscillation. So now it's another challenge for me to figure out how to make it oscillate. Wired SSG charging method. Not only, well, I can get it to oscillate, but to have a periodic oscillation, or whatever other of the dozen other oscillation modes there are. So I'll play around with that now. Okay, I just figured out the how to break up the oscillation with the SSG, and it's working. This is the battery getting charged up, and the ground again is going to the positive of the power battery, not the common ground. So Bedini SSG method, which also disputes all the bogus skeptical claims that if the switch is off, there's nowhere for it to conduct, and that way if the spike is coming out, where's it going to go? Well, hooked up this way, it's going to the positive of the battery, then the negative is going back to the positive of the input battery, and if it's not connected back around the ground, how is it getting charged? But we know that it does. And so anyway, here's the broken up oscillation. Wired SSG method. This is the shunt. This is the power battery. And so we can see that the power battery is receiving the charge, but we can also see right here on that secondary battery getting charged up that it's also getting charged up at the same time. Even better so than connecting it to common ground.